Guten Tag. Hello? Okay, guten Tag. Thank you. Welcome to Chilventa. Um, I'm here to discuss the R-744 PXG. And before I start that, I'd like to draw your attention to climate and how many problems we have in the climate today, how many issues we have concerning heat waves, flooding, tornadoes. And as you all know, when you're addressing CO2 systems, when you're addressing cooling equipment in general, the issues are maintaining the functionality of these systems during heavy heat wave conditions. It's always been a challenge for CO2, and there are many solutions that have been created. And I'm here to introduce to you a product called the PXG 1300, a true innovation in CO2. Before I go to that, I'd like to introduce you to the company Energy Recovery. The company was founded in 1992, and its origins are in energy performance in the desalination business. So it comes from what's called seawater reverse osmosis. And this business is highly focused on recovering energy and saving energy during the processes that are transforming seawater to drinkable water all over the world. So we've been doing this for 30 years, and we have about 20,000 systems operating all over the world. And if you've traveled a lot, the chances are you probably drank some water which was processed with a PXG. So we have a great deal of experience on this, a very unique business. And about 3 years ago, we discovered that this same technology using ceramic could be applied to CO2 systems to alleviate the challenge of high pressure and improve the overall COP of the system, as well as its other innovative benefits, which I will show you in the next slide. So today we have about 50 systems in process in the world, as far away as Japan and as close as Belgium. I would like to draw your attention to the technology itself. If you look at the image on the right for you, this is the PXG in its finished form. So it's a cylinder which is approximately this high, and it's manufactured out of stainless steel, and inside there's a ceramic device which is a rotor and a sleeve. This is manufactured out of ceramic aluminium, and for those chemical people out there, it's formula AL30203. So if that's when you know how this ceramic is made, it's a very sophisticated material. It's about as hard as a diamond. It's absolutely non-corrosive, and it's physically indestructible. So it cannot be destroyed. In fact, you could take 2 elephants that would stand on top of that and it would not deform. Also, it's important to notice that this rotor in the center is about 20 microns tolerance. So it's about the thickness of a human hair. And the CO2 is floating inside this cylinder. So if you were to take this device here and you were to cut it in half, you will see how the pressure exchanger manages the fluid. We're dealing with a high pressure coming from the from the gas cooler at about 100 bar. And that fluid is being drawn into the lower left corner at about 100 bar. And it is, in fact, making contact with medium pressure, LPN, from the liquid receiver at about 40 bar. When these two fluids make contact at the speed of sound, there is no mixing, but there is a transfer in pressure. And the pressure is, in fact, lifted with this device. And then you go from the bottom left to expansion, where the fluid has been expanded and returns to the liquid receiver. And if you go to the upper right, at the HP out, returns back to the gas cooler. So in effect, the PXG is lifting about 60 bar by using these two fluid flows. This cylinder is rotating at a speed between 250 and 1000 RPM. So the speed increases as the pressure increases. As the pressure increases, the exchange increases, and so does the total efficiency. So this is the most innovative device concerning COP improvement, amongst other benefits, in CO2. There are 3 pillars, what you would call benefits, of the system. The first pillar is on the left. You are obtaining a COP lift of approximately 30% at peak performance. That would be at approximately 40 degrees ambient. On top of that, your energy efficiency is between 12 and 15% or even more. We're not sure what the exact maximum could be because we haven't tested it in climates all over the world where it's extremely high, but we will get there. And of course, you're reducing your carbon footprint. The second pillar is stability. Because this device alleviates and removes pressure from the gas cooler, you're having a more stable operation. And when you have stable operation, you reduce flash gas, which means that at 35, your capacity is increasing. You can do two things. You can increase the capacity or increase the load. So when you do have a safeguard, your gas cooler is under less stress. If your gas cooler is in poor condition or not maintained, it will still be under less stress. When we say less stress, it's less pressure. When you reduce the pressure, you reduce the full functionality capacity of the system. So if your gas cooler has been designed for 32 degrees ambient, the PXG allows you to operate it at 38. What do you get for that? You get reduced risks. Do not waste your product or lose product because of lack of evaporation. It allows your system to keep functioning without failure of the high pressure valve. And of course, the discharge failure is the most catastrophic event in an event. When you have a store which shuts down, it shuts down and you lose produce. If it doesn't shut down, your product is still degraded. So this avoids these two phenomena which occur in CO2. And lastly, the third pillar is the OPEX. I'm sure you all have seen CO2 gas coolers equipped with vaporization systems which deliver water to cool down during the higher ambient period. You will not need that. You will not need to set up the vaporization system. You will not need to have a fail-safe system which is only operating 200 hours per year during the peak temp. You will not need any water systems. It saves water. If it saves water, which is very expensive, it also saves maintenance on a system which has to be functional when you need it. So that's the third benefit. And because the PXG has one moving component, the rotor, the overall increased reliability of the system is guaranteed. We have built this into a skid. Why have we done this? Because there are hundreds, even thousands of systems out there which have been operating, which are operating under poor conditions because they were A, designed at a too low ambient temperature, or B, because perhaps the maintenance on the gas cooler or the gas cooler has been degraded. This skid can be fit onto any existing system in the market. It can be used on any systems from 120 to 280 or more kilowatts. It can be adapted. It's a very flexible system. Turnkey approach. So you have everything you need. You have the pressure exchanger, you have the controls, you have the mechanical connections. It's a very smooth, fast integration. 2 days. So mechanical and electrical, the system can be operating. Keeping in mind that the PXG operates over a very large period of over the year. It operates from approximately 15 or 16 degrees ambient to well above 42 degrees ambient. So you benefit from this energy recovery during the whole year, not just during the peak periods. If you would like to look at an example of an application, you have a typical machine room, which is shown on the left here. You have an image of the optimizer, which is our compact cube, which is integrated onto the site. You have the mechanical connection, both delivery and return from the gas cooler, delivery and return from the liquid receiver. And of course, you can operate this through the standard gas cooler already operated, integrated on site, or you can also calibrate it with a separate gas cooler, depending on your application. So the specifications are fairly clear. It's a very compact cube, 60 centimeter by 60 by 120. Let's talk about some more experiences we have in the field today. Now, as you can see on the left, the COP lift, best in class in these different sites, which correlates to the best systems that we have year to date. We're always improving this system. We're always finding ways to fine-tune and lift that cup higher and higher as the ambient temperature increases. So today we are currently operating with well over 30 projects in the field worldwide, as far away as Japan, as I mentioned, and as close as Belgium. We're over 25,000 operating hours year to date. So we're very confident that this system can be applied over a wide variety of applications. The increased capacity, as I alluded to earlier, the graph on the left shows the capacity increase and the COP lift, as well as the compressor mass flow. So you can see by using the PXG, your overall pressure discharge will be avoided, and you will providing a much lower stress on the gas cooler. If there are any questions, I'm ready for them now. Yes, sir.
So about I think it's using a projector.
So could you repeat?
Alternative to ejector?
Yes. The question was, is it an alternative to an ejector? Well, it's a little bit of a different technology than an ejector. An ejector, high pressure ejector, requires the implementation of a parallel compressor and an ejector. Basically, with this system, you can replace the parallel and the ejector. So it performs in a different way because it operates over a very wide range of the annual climate. So whereas the ejector operates in a fairly narrow band of high ambient, above 25 degrees ambient on the gas cooler. So it's a little bit different. Seth, yes. Yes. Yeah. Any other question? Thank you.